Bacterial cells treated with a common antibiotic have been spotted changing shape to survive while aboard the International Space Station ISS. The way bacteria act in near-zero gravity environments could pose a serious problem for treating astronauts with infections. The clever shape-shifting was detected in bacteria being experimented on in the near weightlessness of space, and is believed to help the bacteria survive. An experiment on the common E. coli bacteria subjected it to different concentrations of the antibiotic gentamicin sulfate, a drug which kills the bug on Earth. However, in comparison to a control group on Earth, the space bacteria showed a 13-fold increase in cell numbers and a 73% reduction in cell column size. We knew bacteria behave differently in space and that it takes higher concentrations of antibiotics to kill them, said the study's lead author, Dr. Luis Z. What's new is that we conducted a systematic analysis of the changing physical appearance of the bacteria during the experiments. The paper, published in Frontiers in Microbiology, describes how bacteria operate when they do not have any gravity-driven forces such as buoyancy and sedimentation. Dr. Z said that, this means the only way the ISS bacteria could ingest nutrients or drugs was through natural diffusion. Because the bacterial cell surface decreased in space, the rate of molecule-cell interaction was also decreased. Image E. coli is found in the gut and fecal matter of many animals. The study's authors think this may affect how astronauts are treated if they have bacterial infections. The study also found that the bacterial cell envelope, the cell wall and outer membrane thickened in space, protecting the E. coli from the antibiotic. In space, the bacteria also tended to form in clumps, which Dr. Z thought was perhaps a defensive maneuver, which could involve outer cells protecting the inner cells from antibiotics. Some of the bacterial cells were also spotted producing membrane vesicles, small capsules that form outside of the cell walls and act as messengers for cells to communicate with each other. When these cells reach a critical mass, they can synchronize to begin the infection process. Both the increase in cell envelope thickness and in the outer membrane vesicles may be indicative of drug resistance mechanisms being activated in the spaceflight samples, said Dr. Z. This experiment and others like it give us the opportunity to better understand how bacteria become resistant to antibiotics here on Earth.